And we're off and running, I think. Yep. All right. Guys, we're going to finish the unit today. All right. We got two more formulas. We got the distance formula and the midpoint formula. All right. Distance formula will be a little more difficult. The midpoint will be the easier of the two, I believe. But nonetheless, we're still dealing with formulas here. Let's go ahead and jot this one down. There is the distance formula. Okay. This is the distance formula. That is the distance formula. No, I don't. No, I don't. Nope. Now, distance equals, that is a big radical. That is a big square root. Square root of x sub 2 minus x sub 1. That quantity, that difference is being squared. Plus, and then we've got the difference in the y values. Y sub 2 minus y sub 1. That quantity is being squared. Okay, so keep writing. Now keep in mind, okay, remember those little sub 2 and sub 1 numbers, it's kind of like slope formula, okay? Those are just designating which x and which y, all right? We'll see it here in just a second. We're going to be dealing with ordered pairs of numbers, x's and y values, okay? Guys, it doesn't matter, just like slope formula, it doesn't matter which way you subtract these x's and y's. I would just do them both the same way, okay? Do we want to subtract from right to left, or do you want to subtract from left to right, okay? You make that determination. You do what you feel like is easier for you, all right? But, again, the nice thing is we've got a formula to follow. They're going to give us some numbers to plug in. We're going to take those numbers, we're going to plug them in, and then we're just going to kind of trudge through the formula, okay? Not quite as nasty as the quadratic formula, but there's a little bit more going on with this one, okay? But again, organization, guys, bring things to every step with you. And I know time and space are two things students don't want to give up a whole lot of. Time and space on paper, but use some space, take a little bit of time, write the steps down, bring your numbers along, and it'll work, okay? Does everybody have the formula copied down that needs it? Okay, all right, we'll try one. Okay, so here we go. This is basically what you're faced with, okay? This distance formula, I believe, is used in a few areas there in geometry. Typically, you're given a couple of ordered pairs of numbers, okay? Remember, ordered pairs of numbers describe points on a graph, okay? And sometimes they'll ask you, they want the distance between those 2 points, okay? They might want distance between 2 points as it relates to a certain shape. All right? Possibly working with Pythagorean theorem. I mean, it can be applied in a lot of different areas, okay? But we're going to be very basic with the application here. We just want to become where we can use the formula. These ordered pairs of numbers. Let's go yellow. Please remember that an ordered pair of numbers always comes with an x value and a y value. Okay, so again, you see ordered pair of numbers. I've got an x value, I've got a y value. Both these ordered pairs describe 2 points on a graph. We're going to find the distance between them. If you, and this is your decision, if you want to label the x's and y's as such, that's up to you. Okay, if you want to flip those 1s and 2s and say, you know what, I want the first ordered pair to be x sub 2 and x sub 1, and the second pair to be y sub 1, or x sub 1 and y sub 1, it's up to you. Guys, it doesn't matter. As long as we do these both the same direction, we're going to be fine. I'm going to go from right to left, okay? So when I plug this in, we're going to go distance equals, and we're going to go -4 minus 7. And then I'm going to go -1 minus 3. Oh, anybody see the mistake I made? I made a mistake. What's the mistake that I made? My fault, because I know you're writing this down. I just made a mistake. What am I going to do? That's exactly right. So right here, and I will erase it and correct it, I used a y value where I should be using an x value. And again, I'm probably thinking in my mind a little bit of slope action, but I just made a careless mistake there, okay? So I'm going to take out, guys, I'm going to take out -4, and I need to put -1 right there. And I also need to take my -1 out and put a -4 there. So again, my apologies. So be careful. Be careful. Okay? -1 minus 7, there's my x values. -4 minus 3, there's my y values. Let's go to the next step here. What is -1 minus 7? -8. And -4 minus 3? -7. Just simplify those differences. Okay? Watch for double signs, those types of things. Now, the nice thing is, because we're squaring these quantities, kind of like quadratic formula, because we're squaring a quantity here, guys, it doesn't matter if it's positive or negative. If we square either a positive or negative, you're going to get a positive result. Okay? So -8 squared would be what? 64. And -7 squared? 49. So we end up with a positive 64 plus 49. What is that going to give me? What is that, 113? Square root of 113. Now, just like the other day, okay? And again, want to continue kind of trying to work on this skill. If we end up with a number that's not a perfect square like 113 under that radical, 113 is not on our list, okay? So I can't take a square root of that. Does 113 contain a perfect square factor? And I'm not sure that one does. We can do a quick check real quick. Anybody got a... So 113, it ain't going to be 36, it ain't going to be 25. We'll try 16, that's a no. 113 divided by 9, that's a no. And 113 divided by 4, that is a no. So root 113 cannot be simplified using a perfect square number. 113 is an exact number. That's an exact answer. Leave it there. Leave it there. Okay? If we ever need to, and if they require us to do so, we can always take 113, throw it in the calculator, hit the square root, and that would spit me out approximately 10.6. Guys, we can always do that. We can throw these things in the calculator, get decimals all day long, round them wherever they want us to. But root 113 is an exact answer. If we need a decimal equivalent, throw it in there. Round it to the nearest tenth, 10.6. Questions? Okay with that? And again, trying to talk about it in simple terms. You've got the numbers there in front of you, barring a careless mistake, which the big guy just made, but granted, if we get those plugged into the right places, can we just kind of follow through with the simple calculations? Again, there weren't any crazy calculations there. Okay? All right, let's do it. Again, I put the formula up there. No need to rewrite the formula if you want to. There's the ordered pairs that we're going to deal with. Guys, this time I'm going to go left to right. I'm going to go left to right with my subtraction. Okay? And let's see if I can get it in there correctly this time. What are my x values? 5 and 5, right? Okay, so right here, we're going to go 5 minus 5, quantity squared. I think that's going to be nice. Plus, now be careful right here. We're going to go 1 minus negative 6. 1 minus negative 6. That formula has those built-in minus signs, kind of like slope formula. So anytime we're inserting negative values into this formula, be careful. Okay? Well, 5 minus 5 is 0. Love it. We like 0. What about 1 minus negative 6? What does 1 minus negative 6 really become? 1 plus 6, which would be 7. Again, just be careful. Watch those things. 0 squared. 0. Awesome. 7 squared. 49. And 0 plus 49 is 49. And the square root of 49? 7. That one works out pretty nice. We're able to take a nice clean square root of a perfect square number. Got a 7. All the formulas will be on your review. Of course, you'll be able to bring the review to the test next week. Hopefully, they'll be in your notes as well. Your notes will be available to you. So I may have it on a board someplace, but you should have them in places where you should be able to see them and access them, so you don't necessarily need to memorize these formulas. Okay? Questions? We good? Feel okay about it? 2 ordered pairs of numbers, x's and y's. Question? 1 minus negative 6. Because we're putting a negative number here, and you've got the built-in minus sign. There you go. Good. Watch your signs. Any other questions? Write that down. Good. Okay. All right. Midpoint formula. Now, the midpoint formula is you're trying to find the halfway point, the midpoint between 2 points on a graph. Okay? Now, the midpoint also describes a point on a graph. That's why you're seeing this formula in kind of an ordered pair type of look. Okay? This part right here is going to be the x value of your midpoint. This part right here is going to be the y value of your midpoint. So you are essentially coming up with another ordered pair of numbers for an answer. We need a point described by an ordered pair that lies exactly in between 2 other points, hence midpoint. Okay? And again, all you're doing here, the nice thing about this is we get to add. We don't have to worry about the minus sign. Guys, you're adding your 2 x's together, dividing them by 2. You're adding your 2 y values together, dividing them by 2. So order in this case really doesn't matter. With addition, order's not going to matter. Whatever your 2 x values are, add them together. Divide them by 2, bang. Same thing for your y's. So this formula, a little bit easier to deal with. Kind of visually, it looks kind of eh. But again, those sub 1s and sub 2s are just designated x's and y's. Okay? Any questions about the formula? A little bit easier. All right, let's try one. There you go. We're going to find the midpoint between those 2 ordered pairs of numbers there. Okay? So again, xy, xy. We're going to go midpoint equals. What are my x values?
7 and 9.
7 and 9. So right up top here, we're going to go 7 plus 9. Again, with addition, guys, order's not going to matter. We can add those numbers any way we want. 7 plus 9, 9 plus 7, we're going to get the same thing. And then what are my y values? 4, negative 1. Now, if you want to write it 4 plus negative 1, that's fine. Or if you just want to write it 4 minus 1, that's fine. Same thing. 4 plus a negative 1 or 4 minus 1, same thing. Up to you. 7 plus 9? 4 minus 1? Simplify where you can, okay? If you can reduce the fraction to a nice number, do it. If you can't, just make sure the fraction is fully reduced. 16 over 2 would reduce to what? 8 over 1, or just call it 8. 8 over 1 is not bad either. 8 will work. 3 over 2. Now 3 over 2, not going to divide that evenly per se. Is 3 over 2 fully reduced? Yes. Guys, 3 over 2 is fine. If you write it 1.5, that's fine. 1.5 is a nice decimal. But if you end up doing it, if you end up dividing a couple of these numbers and it gives you kind of a nasty run-on decimal, don't round it off. Just leave it fractional. But something like that, if you wrote it 1.5, no big deal. So the 0.8, 1.5 is going to be halfway in between those two ordered pairs. That's your midpoint formula. Quite a bit, I think quite a bit easier. You get to add the x's, divide by 2, add the y's, divide by 2, call it good. You're finding another ordered pair. Okay, we got one more. All right, let's do one more. There you go. There's your ordered pairs. 4, negative 1, 2, negative 7. We've got an x value and a y value in each. Start setting this thing up here. Easy peasy. What's our x values? 4 and 2. So there you go. We're going to go 4 plus 2 right there. And our y values then are what? Negative 1, negative 7. So negative 1 minus 7. Again, if you want to write it negative 1 plus negative 7, if you want to do 2 plus 4 and then negative 7 plus negative 1, that's fine too. Completely up to you. The addition makes it nice. Let's see. 4 plus 2 is 6. 6 divided by 2? 3. Negative 1 minus 7? Negative 8 divided by 2? Negative 4. Pretty nice when they both divide out pretty evenly. Questions? There you go. That's about it, guys. Just 2 more formulas. This is kind of the formula unit. Quadratic, Pythagorean theorem, which again, kind of like formula, midpoint distance. So we will we'll review on Monday. We will test on Wednesday. And then we'll probably cover one more unit. So that's about it.